Welcome. In this video, I'm going to go over the solutions to the 10.1 mini quiz. So this was over homologous series and functional groups and some basic naming stuff, along with structural isomers. So question number 1 says, which statement about successive members of all homologous series is correct? And I have circled B. They differ by a CH2 group. And because they differ by a CH2 group, that's why they can't have the same empirical formula. They have the same general formula, but that's different than the empirical formula. They have the same physical properties. They actually have an increase or a gradation in their physical properties, like boiling point goes up as they get bigger, etc. And D, they differ in their degree of unsaturation. That's not true because they have the same general formula. It's just a CH2 group changing them. The saturation is going to be determined by the functional group, and that will remain the same for the whole family. Number 2 asked, which of the following pairs are members of the same homologous series? So in the first one, I see this is an alcohol, whereas the second one here is an aldehyde. The OH lets me know that that carbon is attached to a hydroxyl group, but the HO is telling me that the H is attached separately. So the alcohol versus the aldehyde. In this one, they both have OH groups on an inner carbon, so that tells me they're both secondary carbons, or secondary alcohols, or just alcohols. The CO between the two carbons lets me know that this is an ester, COC, whereas the COOH lets me know it's a carboxylic acid with a double bonded and single bonded hydroxyl group. And then the CO here, again, is an ester. I'm sorry, those are ethers, not esters. So an ether in C and an ether in D. And then the CHO group is, again, an aldehyde. So the only one that has the same family in it is B. Number 3, which order is correct when the following substances are arranged in order of increasing boiling point? And if we look at these, CH3 is all nonpolar, so those are just got van der Waals forces or London forces in them. Very weak. The OH, that's a hydrogen bond. And the HO, having a double bonded oxygen, this is a dipole-dipole bond. So the order of strength for these is going to be increasing boiling point. This is going to be the most difficult to boil, whereas this will be the easiest to boil. So the correct order is A, CH3, then the aldehyde, and then the alcohol. Number 4, which organic molecule is not a structural isomer of pentanol 1? So what this tells me is it's 5 carbons and it's got an OH group. So pentanol 2 would be an isomer. 2-methylpentanol, the methyl group means there's a backbone of 5 plus a branch of 1, so this is a total of 6 carbons, so that is not going to be an isomer. 2-methylbutanol is going to be a methyl group plus the butane group, so that is a pentanol isomer, and pentanol 3 would be one. So B is not an isomer of pentanol. Number 5, similar question, which of the following are isomers of pentane? So now we're talking about a 5-carbon alkane. So 2-methylpentane would be 5 carbons with a methyl group off of the second one. So that would actually be an isomer of hexane. Methylbutane would be 4 of them with a methyl group coming off. And dimethylpropane would be 3 carbons with 2 methyl groups coming off. So both 2 and 3 are isomers of pentane with a total of 5 carbons in the structure. Number 6, how many structural isomers exist for C3H5Cl3? So what I did is I drew my carbon backbone of 3. I did it as a straight chain, and I put the 3 chlorines all on 1 carbon at the end. And then I put 2 on the center, which is all that will fit on the center, and 1 on the end. And then I put 2 on the end and 1 on the center, which is still different. And then I put 1 on each, and then I had to double up on the center one. And then I put 1 on each and doubled up on the end, giving me a total of 5 different isomers. And if you named each of these, they would each have a slightly different name. In fact, this one would be trichloral, 1-trichloral, I guess, trichloral propane, whereas the second one would be 1,2,2 propane, and then 1,1,2 propane. And then this one, actually, I have, on these I noticed I've got too many chlorines on here. So let me just pause and adjust my diagram here. Okay, so now there's my 5 isomers. I've taken off the extra Cl on my 4th and 5th one, but there are a total of 5 different ways to draw that with the Cl's occupying different positions on the 3 carbons. Number 7 I omitted because propanol 1 by definition means that there's 3 carbon and the OH has to be on the first oxygen, so there isn't a structural isomer for that. If they've given you the formula C5H12O, then there's 2 isomers for it because you could have the oxygen on the first carbon, or you could have it drawn, as I've shown the other way here. I've actually drawn pentanol instead of propanol, but it could be drawn with the 3 carbons and the OH, or what they really intend for you to have was the oxygen in between as an ether. So just don't worry about that one. But number 8, state and explain whether the following molecules are primary, secondary, or tertiary. So it's really, is the carbon attached to the functional group also bonded to 1, 2, or 3 other carbons? So here's my functional group. This is halogenoalkane. So here's the carbon with the chlorine attached to just 1 other carbon, making it primary. Here's the carbon attached to the chlorine, and it's attached to 2 other carbon, making it secondary. And as complicated as they make this look, they're trying to make it look like it's tertiary or even secondary. But here's the carbon attached to the chlorine. It's only attached to 1 other carbon, so it's primary. Number 9 gives you this structure, and they tell you it's 2-hydroxybenzoate, better known as oil of wintergreen. So here's the benzene, okay? And the reason it's got the O8 name to it is because it's got the CO group here, giving it the O8. And then there's a methyl group attached to it, methyl 2-hydroxybenzoate. And so that's off the first carbon. That's where the functional group is, my ester group. And then here's the 2-hydroxy, the OH group, attached to the second carbon. So knowing that this is benzene, and there's only 1 hydrogen attached to each one, there's really, we can think of it as an alternating double bond, even though the 6 electrons are delocalized. So drawing the full structural formula would look something like I have here. The CH3, the methane group, excuse me, the oxygen connecting to the carbon, and then a double bonded oxygen off the other side, which didn't show up on my picture here. And then that's connected to the benzene with a hydroxy group. And so the empirical formula would be C8H8O3. And then as far as the bond lengths, the 0.1424 and 0.1373 would be referring to the single bond being the longer bond and the double bond being the shorter, which means CO2 should have the shorter bond since it's a double bond on each side. And then all the functional groups, the hydroxyl group, or alcohol you could have called it, the ester group, the COOC, is an ester group, and then the other group is the benzene or the phenyl group or the arene group. Those are the 3 different groups they're looking for. This was all one group as the ester. 2 characteristics of a homologous series: they have the same general formula, they differ by a CH2 group, they have similar chemical properties, and you see a gradation of their physical properties. Ethanol and ethanoic acid can be distinguished by their melting points. State and explain which will have the higher. Ethanoic acid will, because remember, ethanoic acid has a C double bonded O and an OH group, so it's got a dipole-dipole bond as well as having a hydrogen bond. And even though the ethanol has a hydrogen bond with the OH, it does not also have the dipole-dipole bond. So that's going to make the ethanoic acid have a higher melting point because of the greater intermolecular force. Not to mention ethanoic acid will also have a higher mass because they both have 2 carbons, but there's an extra oxygen in the ethanoic acid. So stronger force, larger mass is definitely going to give it the higher melting point. And then part C, draw 3 isomers containing the alcohol functional group for the formula C4H9OH. So you can have a straight chain carbon with the OH on the end, or you could have it on the second carbon, or you could branch that butanol. You could have 1 carbon coming off with the oxygen on that second group. And I thought I had another one here, but this is really the same thing. It's 3 in a row with the carbon coming off. Actually, let me look at this again. Hey, did you just call me? You hung up too fast. I can't get over here that quickly. No doubt. You know what? It's not bad out, but there's dark clouds coming, so I don't know what that means. But if you want to go give it a whirl, I'm up for it. I don't care either way. I'm fine with that. Yeah, let's watch the weather for next week. And next week is supposed to be cool, yeah, but if there's going to be a sunny day, let's go for it. Like if Monday or Tuesday looks good, let me know. Because let me look here. Let me just put my calendar. Monday and Tuesday I don't teach forever. That's just Wednesday and Thursday. Oh, fun. Okay, Monday could work for me, so let's just tentatively plan on that. Okay, well, enjoy your evening. Okay,